Welcome everyone to our lesson today. The book calls this lesson More Multiplication Properties of Exponents. However, you would have heard your teacher last year say raising a power to a power. So let me show you kind of the difference. So on Friday we did the MA problems, where we multiplied our coefficients and added our exponents. So that looked like this. It was a multiplication problem. And what we did, again, if you remember, we multiplied our coefficients. So 5 times 2 gave us 10, kept our bases the same, x, and we added our exponents. So 3 plus 7 would be 10. So that was 10x to the 10th. Today, it's going to look like maybe we take just that first part, 5x to the third, and we raise the entire thing to a power. So it looks very similar, but on Fridays, we were multiplying two monomials together. Today, again, one monomial raised to a power. Okay, so that's the difference between yesterday or Friday versus today. Okay, so we did a quick investigation. It didn't take long for them to figure out the rule, but if I break this up, this is 2 to the third, and I have 4 of them. So if I expanded that, there's 1, there's 2, there's 3, and there's 4. Okay, so I just changed it from a power problem to now a multiplication problem. And if you remember from Friday, I keep the base the same, so keep the 2, and I add my exponents. So 3 plus 3 plus 3 plus 3 would give us 12. And so then I asked the class, how could I go straight from our problem now to our answer? And somebody came up with the rule of keeping your base, but multiplying your exponents. So we are going to use that rule then on the next one. So again, keep your base. And it's kind of like the distribute property. 2 times 3, we multiply our exponents. So this would be 5 to the 6. All right, number 3, again, same thing. Keep your base, a, multiply your exponents, so a to the 4th. Now this one's a bit tougher because I threw in a coefficient. We haven't had any coefficients yet. Okay, so somebody actually figured this out on their own without me having to tell them. But here's the trick, is we have to multiply small number with small number. I can't do big number times small number. Okay, so I'm going to do my w's first. So I know I'm going to keep that base of w to the 6th power. I know that part. It's the 3 part that I don't know. So if you thought about it, when in doubt, expand it out, we would have 3w to the seconds if I actually expanded this out. And so yesterday, or on Friday, we talked about what we would do with our coefficients. You could say that I have 3 3's, or we multiply that out to get 27. So our answer here is actually 27w to the 6th. Another way of looking at this is you can think of 3's exponent as a ninja one. So then you could follow the same rules of doing small number times small number, and that would give you 3 to the 3rd. But again, we don't leave our coefficients like that. 3 to the 3rd is written as 27. That's a better way of writing it. Okay, so let's practice this. But first, if you're doing the notes, go ahead and write in our rule. So when raising a power to a power, we power up the coefficient. So remember, don't leave the coefficient by itself. We have to actually power it up. And then we're going to multiply the exponents. And if it helps you to keep them separate, I like to use these acronyms. Again, on Friday, we did the MA part, which was to, when multiplying, we multiply coefficients and we add, oops, lost my pen there. We add exponents. Okay, we're going to learn DS on Thursday, so that's to come. And then PM problems are what we just did today, is what you wrote down up above. So we're going to power up coefficients, and we're going to multiply exponents. Okay, so that's the difference between Friday and today. All right, so I'm going to go ahead and uncover all of these problems. We can do these 6. Now, in my opinion, these 6 problems, we're starting with the basics. In other words, kind of the pre-algebra information, and eventually we'll get into the tougher part, which is the algebra part, because you guys did learn this last year. We're just going to build from it. All right, so number 1, again, keep your base, which is 11, and we multiply our exponents. Small number times small number, so 11 to the 12th. Number 2, keep your base of 2, multiply your exponents. 5 times 3 would give us 15. Number 3, keep your base of 3, multiply your exponents. Small number times small number gives us negative 24. Now remember, negative exponents, they are no-nos. Can't have a negative exponent. So we're going to make it a fraction. If you remember Thursday last week, we talked about bunk beds. This person is on the top bunk bed and they are unhappy. That's why they're negative. We move it to the bottom and lose the negative. Move it and lose it. So now they're on the bottom bunk and they're happy, and we fill it in with a 1. All right, so let's try number 4 here. And keep your base, multiply your exponents. 3 times 4 is 24. Number 5 and 6 are tougher because they've got coefficients. So I'm going to first keep my base of n, oops, n, not m, and multiply exponents. So small number times small number, which is 12. I'm going to keep my coefficient. Now remember, do not do small number times big number. There is a ninja 1 there. That's 2 to the 1st power. So I do small number times small number. So this is 2 to the 4th. Or when I power that up, 2 to the 4th is actually 16. That's my final answer there, 16 n to the 12th. Number 6 is very similar to that. So keep your base of your y. So that's y to the negative 16th. Again, there's a ninja 1 there. Do small number times small number. So this would be 6 to the negative 8th. And we have no-nos here. So we have to move it and lose it. They're both negative, so they're both going to go to the bottom and lose the negative. And if there's nothing on top, we fill it in with a 1. That's your answer to number 6. All right, here's where we had our commercial break in class, but we are just going to keep on moving here. Okay, so here's where it is a little bit more algebra, especially the next slide is kind of as tough as it gets in this unit. Now, again, we're going to learn DS later this week, so we don't even have that option. First, I'd like for you to identify if this is an MA problem or a multiplication problem, like we did last week, versus what we learned just now, which is a power problem, raising a monomial to a power. Okay, so number 1, we have a monomial raised to a power. So this one is a PM problem. So this is what we did today. So again, we're going to keep our base of the y, small number times small number, that'd be 8. And draw in your ninja 1, small number times small number, this would be 3 to the 4th. Again, we don't leave it like that because that number is better written as 81, y to the 8th. Okay, number 2. Notice we have 2 parentheses here. This is not raising something to a power. This is the MA that we learned last week. Okay, so M stood for to multiply coefficients, 3 times 3, 9. And the A stood for adding your exponents. So we kept the base and we add our exponents to get 6. So 9y to the 6 would be our answer on this one. Number 3. We have 2 sets of parentheses here, no exponent outside, so again, another MA problem. So multiply coefficients to get 12, keep your bases of the H, and add your exponents to get negative 6. But we have that no-no that we can't have a negative exponent. And be careful on this one, because 12's exponent is technically that ninja 1. It's positive. It stays up top, but the h moves to the bottom because it was negative. All right, number 4. We don't have two things we're multiplying. Here we have something raised to a power, so this is a PM problem. All right, so keep your base of the h, small number times small number, so negative 16. Our 6 is our coefficient, but it has an exponent of 1, so small number times small number to get an exponent of negative 8. And last, we have a no-no. We have actually two no-nos. We gotta clean those up, move it and lose it. So they're both negative, so they're both going to move to the bottom and put a 1 up top. All right, so on some of the homework tonight is to just decide which one you are using. And then here is the toughest part of the homework, is when I have both MA and D, and not DS, and PM in the same problem. So if you're thinking in terms of order of operations, this stands for multiplication. This stands for raising something to a power or to an exponent. In terms of, please excuse my dear Aunt Sally, which one comes first, multiplication or exponents? Well, E comes before the M, so we need to do the PM part of these problems first. That comes first in terms of order of operations. Okay, so that's what I'm going to do on these next 3 problems. Again, this is as tough as it gets, and this is more of the algebra part versus the pre-algebra. I'm going to pull out the PM part of the problems first. Okay, so I'm looking for parentheses raised to a power, and I can see that right here on this first one. So this is the PM part, and this is what we just did. So small number times small number, y to the 8th. There's that ninja one, small number times small number, this would be 2 to the 4th. Again, I would clean that up. 2 to the 4th is better written as 16 y to the 8th. Okay, but I'm not done with the problem yet because I had that y to the 5th out front. So I still have a y to the 5th, and it's right next to those parentheses, so that means multiplication. All right, so now I just switched from a PM problem to multiplying. So this is an MA problem now. I'm going to multiply my coefficients, which all I have is a 16, I guess technically, and a 1. So 16 times 1. Keep your y's the same, keep your bases. Add exponents, 5 plus 8 would give us 13. So our answer here is 16y to the 13th power. All right, we're going to try the same thing on the next one. I'm going to do the PM problems first. So you're looking for parentheses with an exponent outside. Here is one PM problem. And this one actually has 2 PM problems. I'm going to do this one in green. So parentheses, exponent out front or outside. So another PM problem. So I have to do 2 parts first before I can do anything else. So keep your base. Small number times small number gives us 6. So that's the first PM problem. The second PM problem, again, I'm going to keep my base of my M. Small number times small number, so 4. And draw on your ninja 1. Small number times small number, this would be 7 squared, which is better written as 49. I'm going to bring down my M to the 6. Now those 2 parentheses were right by each other, so there's multiplication in between there. So now it switches from PM problems to MA problems. So we're going to multiply our coefficients and get 49. Keep your bases of M and add your exponents. 6 plus 4 would give us 10. Okay, we're going to do number 3 here. Again, pull out the PM part of the problem. So this parentheses 3y does not have an exponent outside. So that's not a PM problem. Same with y to the 5th. But the middle one does have an exponent outside. So this is the PM part we need to do first. So keep your base of your y. Small number times small number, 4 times 2, 8. There's that ninja 1, 4 times 1. So this is 2 to the 4th. And I'm going to go ahead and clean that up. 2 to the 4th is 16y to the 8th. All right, now I'm going to bring down my 3y. And again, they were right by each other, so there's multiplication going on. I'm going to bring down my y to the 5th. Again, multiplication when they're right next to each other. So this has switched to an MA problem. So we're going to multiply coefficients. So 3 times 16 would give us 48. Keep your bases of your y's and add our exponents. So we've got 5, 8, and our Ninja 1. That would give us to the exponent of 14. So 48y to the 14th. All right, you do have homework tonight. I have provided the answer key. Please hit me up if you guys have any questions. All right, see you soon. Bye.